Hey guys, happy Monday. Happy Monday. Ugh, gross. Today is an exciting day for me because this is the first video I'm posting that isn't for a conference. That's right, I made it just for you. I'd like to start making more of these videos because I've been working from home for the past year and a half, and sometimes I love it.
But other times it feels really hard.
And one thing I've learned about myself is that apparently I'm really good at falling down these research rabbit holes, and I'm not real good at getting out of them. So these videos are going to be my personal way of trying to close the book on some of these endless quests. And who knows, maybe someone will even find them helpful. Now, having said that, let's dig in. As probably most of you already know, I use reflectivity data from the Cygnus satellites to try to infer changes in surface soil moisture or inundation extent through time. And my latest rabbit hole started when I decided to have the bright idea of taking another look at the data over the Sahara Desert in North Africa. In the past, I had used the Sahara Desert to empirically calibrate my data, because aside from some occasional precipitation, I had figured that not much was changing about the surface.
Oh, I was so wrong.
So I was looking at these reflectivity time series, and I was comparing them to soil moisture time series from the Soil Moisture Active Passive, or SMAP, satellite. What I wanted to see was a good correspondence between reflectivity and soil moisture, because this is an indication to me that the data are behaving like I'd like them to. And it was all going great. I kept looking at these reflectivity time series, and I was like, man, this is gonna be a piece of cake. I mean, this one looks great. Look at this one. It's so pretty. I'm so good at this. What the?
Turns out it wasn't a piece of cake.
The last time I had taken a hard look at these data in this region was probably in early 2019 when I was making a Cygnus soil moisture product. But since that time, something weird had happened to some, but not all of the data. My first thought, as it always is to assume that I had really messed something up.
What do you think it means that I always assume everything is my fault?
But I checked and double checked, and the data were correct, which I should have known in the first place because most of the data were fine. So then my second thought was, North Africa is pretty close to the Middle East, and we've known for a long time that GNSSR data are affected by what's called radio frequency interference, or RFI. Basically, somebody can set up a GPS jamming device that makes it more difficult for you to use GPS for navigation, and the Middle East, unsurprisingly, has a lot of RFI going on. So I decided to dig into this a little more to see if the reflectivity data really are going crazy because of RFI, and if so, if I could either remove those data or maybe even fix them. The first thing I did was I plotted how the noise level of the delayed Doppler maps, or DDMs, changes over time. So I should probably explain what I mean by the noise level. So here we have a really typical DDM where the y-axis is delay or time and the x-axis is Doppler. And those colorful pixels are the GPS reflection itself. And the peak value of the DDM is what I interpret to be the reflectivity. The noise level of the DDM is the mean level of the pixels that are recorded before the reflection comes in. So I plotted the mean noise level in both space and time, and what I'm going to show you next are monthly averages of the data over the Middle East, and I'm going to start in January of 2018. And as we go through the first few months, I saw exactly what I thought I would see, which is pretty consistent noise everywhere, with increased values over the Middle East that get slightly worse through time. But then as soon as we get to June of 2019, things get weird.
Dang, Livia, what are you doing?
Noise increases by a lot. And with the exception of like a little bit of fluctuation here and there, it really stays high. And this increase in noise is exactly when reflectivity in the same region gets super weird and no longer correlates with soil moisture. So it seems like reflectivity in both North Africa and the Middle East are being affected by RFI. And in mid-2019, RFI starts going bananas in Libya. Now the question is, can I fix it?
Or should I just quit?
I will address that question in my next video, but the answer might not be what you think.